Hello, world! Welcome to the show. Today we have a big show, and with me I have Amy. Hello, Amy. How are you?
I'm very good, thank you, Frank. Thank you for having me on the show. It's good to be back as a co-host, and with an exciting new format.
Oh, yeah. So the other day we were chatting together, and we were wondering, like, hey, where? Like, that's the question people ask you. Like, what people ask you the most as a question when you do conferences and stuff, and it's always.
It's always where do I put my data, or what's the right place for my data, or how many different data stores are there, and how do I choose between them? It's honestly just a question that's always asked. And sometimes having these things side by side and being able to say, right, I need a bit of that and a bit of that, and actually maybe these things can work together.
Yeah. So we invited a bunch of specialists, different product manager on the product of Microsoft, to try to clarify that question. So who did you bring it with you today, Amy?
We have 4 experts who are going to really drill into their different products and how we can use them. So up first, we'll have Jeff King. Jeff, tell us a little bit about what you're going to talk to us about.
Yeah, hi Amy, hi Frank. I'm going to talk about data lakes and some of the common practices and questions that we get with data lakes, or we get from customers about how to implement their data lake. So yeah, I hope it's going to be useful.
Wonderful. After Jeff, we're going to have Vincent, and Vincent's going to be talking to us about
Azure Data Explorer, Kusto, and how you can use it and when to use it to analyze your big data, your time series, telemetry, and logs.
Amazing. Cool. So that's 2, but we've got 4 experts. So up after that will be Mark. Mark, what are you going to chat to us about?
I'm going to talk about Azure Cosmos DB, and we'll talk about how Cosmos is different as a scale-out database, kind of the scenarios why you would use it, and where you see it, or we see it being used today.
Wonderful. And in case we forget, Mark's got a nice animated GIF just behind him so that we know exactly what product he's related to.
No
and then up last but certainly not least, we have Savine. Savine, tell us what are you going to be chatting to us about?
Well, the other 3 are going to tell you about different places where data can be in Azure. And I'm going to wrap it up with, if you need analytics on that data, how Synapse is that answer. Any data you have, you can use Synapse to understand it and drive your business with analytics.
Nice.
That's pretty cool. That's pretty cool. I'm wearing my T-shirt for the occasion, Data Nerds. Want to make sure it was relevant. Data. So I thought, it makes sense for today. So very happy about that. Did you have the glimpse of there was a big announcement today about Microsoft, like sharing the new hardware and stuff? Did you watch that?
Frank, I have not. I've been too concerned about this show that all I've been doing is prepping, but I know I've got a lot to catch up on because you've already filled me in.
But you know what? Tomorrow they are coming on Hello World.
Oh, wonderful. Well, I'll watch Hello World tomorrow then. I'll get a lovely summary.
Yeah, wonderful. But before that, now it's today. So let's start with our first speaker, who it is.
So up first, we have Jeff King, and he is going to touch you a bit about the features that he works on in the Azure storage team. So, Jeff.
Yeah, hi. Thanks, Amy. Yeah, I'm Jeff King. I'm a program manager on the Azure storage team. I focus primarily in the world of big data and analytics, so that puts me squarely in the world of data lakes, since Azure Data Lake Storage 2 is a part of Azure Storage. And my currently my focus is working with customers and in the areas of migrations, right? So helping customers migrate and modernize their current data estate, whether it be on-prem or wherever, and into Azure Data Land, and predominantly they want to start in the world of data lakes, right? They want to get out of the data silos and into sort of data democratization, right? And that's where data lakes really shine. And ADLS Gen 2 is obviously, Azure's answer to data lakes, right? So it's a real exciting time for us.
Absolutely. And Jeff, you spent some time with Frank earlier in the week. And before we play that video, though, that you and Frank are in, make sure to get all your questions in the chat. Jeff's going to be in the chat. All our other experts are in the chat whilst we show you this video.
Awesome.
Let's roll the video. So, Jeff, briefly, what's Data Lake?
A data lake is a file system that's meant to store, petabytes, exabytes worth of data that you want to later do some analysis on, right? You want to run some big data analytics workloads on, and you want to do it at scale, and you also want to do it in a cost-effective manner, right? We'll go into the details of a data lake a little bit, as we dive into this, but for a high level, that's probably good enough.
Okay, good enough. So where does it shine? Like the question of today is, where should I put my data in? So where should I pick Azure Data Lake?
If your data is going to be analyzed later on, and most data usually is, whether it's log data, IoT data, sales data, whatever kind of data, today's enterprises, almost always will need to do some analysis on the data that they either ingest or generate themselves. ADLS Gen 2 or Azure Data Lake Storage Gen 2 is the place to put it. Azure Data Lake Storage Gen 2 is essentially a set of capabilities on top of blob storage, right? Blob storage has been around since the beginning of Azure. So what's that, 13 some odd years now? And essentially ADLS Gen 2 is a set of capabilities that sit on top of blob storage, right? So it gives you hierarchical namespace, gives you file system, gives you sort of ACLs, and granular security controls, and a bunch of other stuff.
And so these days, so you mentioned if people don't know, Azure Storage, it's everywhere. It's used on all other services. It's hidden if it's not visible. So
right.
It's super old. So what's happening these days with in the data lake world?
It's actually a very exciting time. Data lakes are in sort of the lake house architecture or pattern is becoming very, very mainstream. Customers are voting with their wallet, as my accountant father would say. Oftentimes these customers are becoming very, very, how should I say? They are becoming aware of the cloud scale that public cloud platforms provide them, but yet they are, and they want to take advantage of that. So they're often migrating from on-prem. And usually what happens when they migrate from on-prem is they're either coming from, say, a traditional Hadoop environment or a data warehouse, for example. And either, they look at a data lake and they say, oh man, I want ubiquitous data access, irrespective of which tool or analytics tool I might want to use over that data. Or, oh, wow, that's very cost effective. We could save a bunch of money, not by switching to Geico, but by actually switching to a lake house or a data lake environment versus, a more expensive, data warehouse, right? I mean, we're not talking about maybe, 100 terabytes. We're talking about petabytes, right? And some customers are in that exabyte level of data. Trying to implement a data warehouse over petabytes of data is going to be prohibitively expensive for most organizations. So, this is why customers are, we're seeing customers picking, and choosing a data lake or in a lake house architecture to, as their next home, and sort of the base, the fundamental to their analytics, solution and in the cloud, in this case, Azure land. Yeah. So it's very, very exciting times, Yeah.
Well,
I'm so excited.
Brilliant. So again, is there best practices for us who would like to get started on that Azure Data Lake?
Yeah, I wanted to spend this time with you and the lovely audience talking about sort of what we have, some of the more common questions and patterns, as well as some anti-patterns that that we have seen, we in the product group have seen here in the last, last few years since ADLS Gen 2 has been around. And yeah, we kind of dive into that. You've got a bunch of other demos lined up in this session, so I'll leave it to those folks to drive that. So some of the most, usually where we start when we have a conversation with the field or with the customers is like, or usually the first question we get is how should I be organizing my data? Where should I be, how should I structure my lake? And, there's a bunch of other questions, and we've actually created, and before I dive into that, let me show you like what we've built, right? Some of these common questions, we've actually consolidated them, and we've created what we call the Hitchhiker's Guide to Data Lake, or to Azure Data Lake Storage Gen 2. Mm-hmm. And this guide is I'll show you some of the interesting parts in here. This was actually created in conjunction with some of our more prominent folks in the field who have been working, on the ground alongside the customers who are building their, sort of data lake based analytics solution, on top of ADLS Gen 2, right? So these are basically real questions from real people, and they weren't sort of thought of in a vacuum with within product group land itself. So very, very relevant, especially if you're a customer or someone in the field trying to help a customer on the ground. So as I was saying on that. Going back to that first topic is, how do I organize my data, right? Or should I, even more high level from that, how should I be organizing my data? You need to be thinking about either a centralized hub and spoke model or a federated model. A lot of times this is going to be predicated on what sort of regulatory requirements and data privacy requirements that you have. So we have a section in here, along with some of the considerations. You should totally check those out. Another thing that you want to folks often ask is, how should I manage access? As with Azure Storage being around for a long time, you've got the options. You got the same options that you would have in normal Azure Storage, but then with ADLS Gen 2, we've added these granular ACLs or that you would typically get in a Hadoop environment or a file system environment. And there are some do's and don'ts with this, things like, when should you be using, role-based access control versus ACLs, and as well as sort of the benefits and trade-offs of, one option versus the other, right? And real quick, let me kind of just drive into some of the other things like data format. That is such a common question. What data format should I choose? Honestly, I like to keep it really, really simple, stupid, right? Like, oftentimes your raw data, your data is ingested. It's going to be in like, row format, like JSON, XML, CSVs, and so on. That data is probably going to land in a raw zone or sort of a staging zone anyway. You're going to probably convert that format to a column-based format. Which one? You've got options, right? You got ORC, Parquet, Delta, and one or two others. At this point, it's like, well, what's going to be your tool of choice, right?
So much information, Jeff. I need to stop you. The time is flying. We'll make sure to share this gold mine in the show notes. Thank you for your time.
Thank you. Great. It's been a pleasure.
The unstoppable Jeff.
Cringing.
We still have a few minutes for questions. So I see a question in the chat. So it's a long question, so I will try to read it correctly.
Sure. Okay.
So it's about the life cycle policies with premium tier for Azure Data Lake storage. Is there a roadmap for having life cycle on premium?
Yes. So that's it. So the person who's asking is probably alluding to the fact that premium, if you set up ADLS Gen 2 and in premium, so premium ADLS Gen 2, you're unable to automatically tier down to a hot or cool or cold tier or even archive tier. And instead you have to set up a different account. So we're actually planning to close that gap in the very, very near future. So stay tuned for that.
Yeah. So sorry. I was reading the chat, and I'm apparently I'm bad doing multitask. Do you have any question, Amy, for us?
Yeah, so I think there was one. Jeff, can you just double check, clarify for us? Storage Gen 2. What does that mean if people have been in the Azure space for quite a while and they might have seen other names?
Right. Yeah. So in order to be a Gen 2, there has to be a Gen 1. And so when before ADLS Gen 2, there was just Azure Data Lake Store, and that was a separate service. And what we've done is we've essentially evolved that service to essentially be built on top of blob storage, taking the advantages of what blob storage has been bringing in terms of it's in every region, it's cost effective, it's rich with features, so on and so on. And then and essentially we took the benefits of ADLS Gen 1, hierarchical namespace, support for big data workloads, things like that, and put that on top of blob storage essentially, and that's what you have ADLS Gen 2 or Azure Data Lake Storage Gen 2.
Wonderful, thank you.
Yep.
Jeff will continue to be all along for the show in the chat, so if you have more question, ask him. He's over there waiting for you. But now, Amy, who's coming next? I think it's Vincent.
Yeah, we have Vincent with Azure Data Explorer. So hey, Vincent, how are you doing?
I'm doing very well. How about you?
Oh, good. So we've just heard all about Data Lake. On to Azure Data Explorer. I know you. Tell us a little bit about yourself. Who are you in the Azure Data Explorer world?
So I'm a program manager on the Azure Data Explorer team. I do focus on the developer experience of the Azure Data Explorer, so the way that the developer will interact with the platform, and then we'll automate everything from deployment, testing, and monitoring tests during the runtime. But otherwise, I do speak to a lot of customers across the world to make sure that they have a great experience with the product.
Great stuff. That sounds awesome. And well, you also met with Frank and gave us a really good explanation of Azure Data Explorer. So let's take a look at that.
Great.
Vincent, what is Azure Data Explorer?
Azure Data Explorer, or ADX, is an analytics database. So analytics database means that it's not a transactional database. It means it's something that you use to analyze your data instead of storing your data as a master rubricate. So ADX is an analytics database. Something special about ADX, it excels in time series and searching text or unstructured data. So it can support structured data, which is your typical schematized data, semi-structured data like JSON, and unstructured data like text. You can pass text along. It can scale to petabytes of data and can return a result of a query within seconds or even under a second sometimes. So it unbelievably is fast, and it's able to do that because it compresses the data automatically and it indexes the data automatically.
Oh, that's cool. And what's the query language? Is it SQL?
No, it's Kusto. So Kusto as an homage to Jacques-Yves Cousteau, the French Sea Explorer. So Data Explorer is to explore your data. We have Kusto as the query language. Let me show it to you actually instead of.
Yeah, let's bring your screen.
So here I have that's called the web UI for Data Explorer.
Okay.
I have a database. It's a demo database with a GitHub data set. So the first thing I'm going to do is to do a count. So this is Kusto. I start with a table name, and then I do pipe, and I do operators on that data. And I can do multiple operators. It's like a data flow. It's a data flow model. So yeah, I counted the number of rows I have in my table. So it's 1 billion rows. It's about 3 terabytes of data, the data set, if you would look under the hoods of that database. If I look at the table, I can do a limit 10, so that's like a top 10 in SQL. And you can see I have a couple of fields. I have integers, a string type. Then I have some field in JSON and some more fields. So something I would like to show you is I can go actually inside the semi-structured data or the JSON field and in the repo column. I'm going to go and set the name. So I'm going to say, okay, GitHub project is like a select. So I'm projecting just a name. So I'm taking repo.name. So I'm going inside that field, taking that name. Then I take the result of that, which is going to be just one column name with all the names for each row. And I'm going to filter for the name that has Kusto in it. So to detect the repo name that has Kusto in it, I'm going to select only a distinct data set of those names. And finally, I'm going to order it by name. So if I run that query, you see it runs very fast, 0.2 seconds, and gives me 38 records with all the repos inside GitHub that has Kusto.
That's pretty cool. That's pretty cool. And honestly, like I'm familiar with SQL and KQL, Kusto.
Yeah.
Yeah, it's very. It seems very simple. So the question of the day is, where should I put my data? So can you tell me where Azure Data Explorer shine the most? Like for what kind of data should I use it?
Yeah. So the perfect scenario for Azure Data Explorer are logs, telemetry, and time series. So any type of data that is happen only. So telemetry, like IoT devices, telemetry is data that will keep coming in, maybe at a very rapid pace, but it's not something that you will go back and edit and do an update on the data. And those create time series that you want to analyze in the future. And typically, you're interested in the latest data. So maybe you're interested in the last hour of data, or you're interested in last day, last week, last month. But you're interested in that time window that's most recent. So that's the best case scenario for ADX. This is where it's most performant and useful.
Okay. And like you show us some queries earlier, so can I save those? So like, or like, can I interact with code with that? Can I run automatically some queries?
Yeah. So in the tool I show you, the web UI, you can it actually will remember your query. So it's working with cookies, and it will remember that. There's a desktop tool that's called Kusto Data Explorer. It's so it's a smart client running on Windows, and you can save the queries in there. So there are many ways to process your queries. And,
wonderful. So I will make sure to put all the connections inside our show notes so people can find those and like open it straight from the web or download them and install them. That's cool.
For sure. And we even have, I'll share a link with you that you can actually learn Kusto. By the way, Kusto, you can learn, I learned it in 2 hours on a Friday afternoon. And there's a documentation where you can click and you can actually interact with the sample database without signing in for anything. So
I love that. I love that. Yeah, let's put that in the show notes. And so I can interact with that with my app because there's API. How that works? Yeah,
so to integrate, if you would like to integrate an application, you can go with the REST API, like many or all Azure services. Are APIs available, and there are a layer of SDK built on top of those APIs. So we support 5 languages. We support C#, Java, Python, Node, and Go. So we have SDK that you can interact for either ingesting data or querying the data. So people will do that. Very often what we see, they will expose like a search of their data in an application. So instead of exposing directly the query experience that I showed you, they will expose like an advanced search. For instance, you can type some text and find some things, and the application will translate that into a query. The second biggest integration we see with applications with dashboards. So as I mentioned, Kusto is really good for telemetry data, so very often we'll want to have dashboard to show what's going on with our operations, basically.
Oh, wonderful. You know what? I need to start digging into that. Thank you a lot for your information.
Thank you for your time, Frank.
That was cool. That was cool. We are a big user of Kusto and all those tools internally at Hello World, so very happy to have you on the show.
Right.
Chat is in fire, so let's jump right to it. So I have Madhu that is asking, in fact, they're saying they're blocked right now with ADX DevOps compatibility, and they would like to know, do you have any roadmap with DevOps features?
Yeah, so I don't know what specifically they're referring to. If they want to contact me on LinkedIn, please do so. What I can tell you is that we're investing heavily right now to improve the deployment of ADX, so to make sure that you have an experience end-to-end for both ARM templates and Terraform, so you can deploy all the way from your ADX cluster to the actual database and tables and all these schema objects. So we'll have that this semester, so the next 6 months. We also invest in the testing so that we can do unit testing for ADX. So I can't give any specifics right now because we just started to design that part, but that's quite an exciting time to come. So there's lots of investment coming down the way for DevOps and DataOps.
Awesome. Cool. Thanks.
That's really, really good. Speaking of using Azure Data Explorer, so in Azure Data Explorer, you showed us you were kind of writing those queries, and that was calling into a database. How does clusters, databases, tables kind of break down in Kusto?
Sure. So Kusto is a scale-out architecture. So it's multiple VMs under the hood. You don't manage the VMs, you don't see them, but it's a cluster. So it's a cluster of multiple VMs, and you can scale it out, scale it in, change the SKU of the VM. So a cluster has multiple databases, or potentially multiple databases, and each database will have multiple tables. So that's the hierarchy. This is from cluster to database to tables. And each tables will have multiple columns and rows for sure. And so that's how you can do it. You can so then you can play with the security. For instance, you can have databases for different departments in your company. We see some customers doing multi-tenant scenarios where they get they'll have a database per customer, for instance. You can play with the security like that, and you can share the data as well. You can do cross query between databases. There's no penalty to do that.
Amazing. Yeah, I was going to say, when I first went in there and I kept using all the wrong terminology. I kept saying like, oh, the database, but I actually meant a table or something like that. So thank you for explaining that one for us. Our next question actually is more around, so I love a query. I really enjoy spending a lot of time in Azure Data Explorer with the queries, but when a lot of people don't want to be in that kind of view, how does it connect to visualizations and stuff like that? What are our options?
Yeah, so I think I didn't demonstrate that in the video that we showed with Frank. You could actually integrate visuals within the queries. At the end of a query, you can always say pipe render, column chart, or different types of chart. We suppose so right in the Explorer, you can actually do visualization. Otherwise, it integrates with a bunch of different tools like Power BI, Tableau, Grafana, so you can export or visualize your data using third parties or first party tools to do dashboards or graphs.
Wonderful. That's a good tool.
Amy, I think if we need to move on. There was a lot of question going on, but let's bring the next guest, who it is.
Sure. So up next we have Mark. Mark is from Cosmo DB, in case we can't see his animated GIF. Welcome, Mark. Welcome, Mark. Tell us a bit more about who you are, what you do at Microsoft.
Yeah, I'm Mark Brown. I'm a program manager on the Cosmos DB team. I do a couple of different things. I manage all of our resource provider APIs, so that's kind of the control and management plane. So any ARM templates, PowerShell, CLI, Bicep, all that stuff is what I own. I also focus a lot on our outbound and community efforts. I run a weekly podcast as well. You can come check me out on gotcosmos.com/TV every Thursday.
Nice. We do always like to offer people other things to go do. Maybe we can cross promote. You call out Hello World next time.
Yeah, sure. I'll get Frank and you on my show.
Oh, perfect. Yes, we would love to. But if you want to go and check out that podcast, in the show notes just below. But Mark, just as with our other experts on the show today, you got a chance to chat with Frank earlier in the week. So let's take a look at that video and we'll be back for Q&A.
Sounds good.
Mark, how Cosmo DB is different than other databases?
So Cosmos is different in a couple of different ways. First is Cosmos is a scale-out database. We're horizontally scalable. So unlike say, a relational database where you're going to scale up by increasing the size of your VM. In Cosmos, you just keep adding additional nodes or compute or partitions, we call them, and you get additional size in that. And this is great because it does provide unlimited storage capacity, and theoretically unlimited, because you can just keep adding different pieces of compute. The other thing it does too is because each of these pieces of compute can process requests, you get unlimited throughput as well for your databases in Cosmos. The other big difference too for us is Cosmos is non-relational. We don't put locks on your data, so we're not going to lock a piece of data to read or write from it. We don't enforce relational constraints, foreign keys, any of that stuff. And the reason is because we're really designed for kind of that high performance kind of scenario. So we don't want to put locks on data. The other thing too is because we're a scale out, you would have to put distributed locks across these different nodes or partitions, and that's just not good from a performance or availability standpoint. Speaking of which, so because we have this scale out thing, as I mentioned before, so we scale out and add different nodes in there. We call those partitions within Cosmos DB. And so the way you see this is when you create a new collection or container in Cosmos DB is you specify the partition key. And this basically helps us route the data, whether you're writing data or you're reading data. Like here, I've got one that's username of Andrew, or excuse me, partition key of username. So if I want to write data to my Andrew partition, I include that in there, or the Mark one, or the Tim there, or the Tim one there. And then on the read path, it's important then I want to use that partition key when I'm trying to find my data. So here I've got this query, select star where C username equals Mark, and that's our partition key. So when I pass in that value, I know exactly where to go and get the data. And this allows you to write really high performance queries within Cosmos DB. So that's kind of the big difference, is that horizontally scalable and non-relational.
Oh, okay, so now I know why it's different, but why would I care? Why should I pick Cosmo instead of something else?
Sure. So that kind of horizontal scalability allows us to have a high amount of elasticity with your throughput, right? Because we can just keep adding nodes and adding more throughput, more storage to your account. In fact, we can do this with no downtime. So you just increase the throughput on there. We'll go behind the scenes and increase the amount of storage and throughput that you can handle within there. We're also a regional or multi-region database. So we can replicate data into any region in Azure and then make that available to serve reads. And we do that and maintain the consistency of that data across any and all regions. The nice thing too is because we're multi-regional, we can survive regional events. So we can provide higher availability than, say, if your database was just running in a single region. Also, even within a region, we have multiple copies of your data. So we have what's called a replica set in Cosmos, and we write your data 4 different times within that region. We maintain a quorum over that data. So we'll maintain a 3-quorum replica quorum for that data. So if one of the replicas happens to have an issue, that's okay. We can maintain the availability and still read and write data in and out of your account while we get another replica filled in its place. Lastly, we can also co-locate these in availability zones, which is great because now you can survive, say, a zonal outage if that happened within a region as well. So we're really built for kind of that elasticity, that availability, and that high write volume within for workloads.
Very interesting. Okay, so now we know why we should care and everything. Could you help us, like by giving us, like in 2 minutes, or about different scenario where like Cosmo DB will be a good fit?
Yeah, of course. We see lots of different workloads where they want one of those 3 different characteristics, whether it's the elasticity, the availability, or that high write volume. IoT workloads is a good scenario where we're ingesting large volumes of device telemetry, and that's great because you can just provision more throughput and ingest more and more data. Another one is e-commerce, and they love us because of that scale, because they can quickly scale up if they need. Also, e-commerce, they really value availability, right? Like there's nothing more painful or costly than if you can't sell anything. So having a database that can maintain high availability is important for them. Manufacturing is another one. They use us for parts list, supply chain, financial services, particularly payment processing is another huge scenario for us, both from elasticity and scale and availability. Anything where a document would make sense for storage is a workload that we see usage. Also, workloads where maybe the schema is quickly evolving, or maybe where there is no real schema is enough. There are workloads where you see people using Cosmos.
Yeah, because of that flexibility, it's easier to adjust.
Right. We don't. So that's that fundamental difference of non-relational. We don't enforce schema at the database level. You enforce it at the app level.
And also, there's many different APIs. So, like as a developer, like I could use many different way to communicate to Cosmo DB. Am I right?
That's correct. We're multi-model, so we have our own core, what we call SQL API. It's a SQL flavor over JSON data, but we also have support for MongoDB, Gremlin, Cassandra, even the old table storage. We have support for that as well.
The old.
The old. It's been around for a long time.
Yeah, I know what you mean. I just, it's
the old. Sorry, I don't mean to disparage my table.
But okay, perfect. Thank you. So you know what? Let's see what the chat has for a question. Thank you for your time.
You bet.
I was still laughing.
People.
I didn't see any question yet in the chat. So if you're there, feel free to chat with them, ask them questions, provide feedback on your experience. Those PM are there for you for the entire hour. So feel free to reach out in the chat. They're there. They're just waiting for your question. But Mark, I have one question because
Sure.
I know it's a very important first step when you start with Cosmo, and is your partition. So I know that, let's say, last name is not a good way to partition, but I don't know, like, does the date is a good one? Or like, how do I know what the
Yeah, interesting. So we see this question a lot, and it's a fair question, and as people are trying to wrap their heads around how partitioning works. But consider if you use date as a partition key. If you have an application that's write heavy and it's writing the current date all the time, and you're partitioning by date, you're going to get a hot partition. Like, all the data is going to want to write to a single partition. And that's actually something you really want to avoid in a database like Cosmos. You provision all of this throughput. We create all of these physical partitions behind the scenes that are there to serve read and write requests. The idea there is, when you provision that throughput, we spread it evenly across all those partitions. So you want to spread the load across them. So in a write-heavy workload, data is actually not a very good partition key. You want to find something else to help spread those writes out across as many partitions as you possibly can, so that you can avoid that hot partition. It basically acts like a bottleneck.
Yeah. But maybe you want to clarify, because I know, because I learned it myself trying the last name, but why like a last name or a first name won't also be a good idea most of the time?
Well, that depends. I mean, if you were last name,
because most letter will get clutter and other will be empty.
Sure. So I mean, if you were using like a letter or something like that, the first letter of their name, your X partition probably going to be, or Z or Y, probably going to be relatively empty, and other letters with, where you have more names are going to be busier. Another one that wouldn't work well either is maybe zip code. Some zip codes may have higher density of people than other zip codes. Here's the thing. It comes down to, what is your workload and how does it behave, and understanding the access patterns to your data. That really, at the end of the day, is what should drive or inform what your partition strategy should be. And understanding how do customers or users interact with that data? How are they writing data? What data are they writing? What frequency do they write it? How do they read it? And then just, you have to understand that volume. There's really, in a sense, it's, from a write-heavy perspective, you want to spread that load across as many partitions as possible. But on the flip side, for a read-heavy workload, you want to serve queries from as few partitions as possible. Whereas in the write, you want to spread that load across as many partitions as you can. On the read path, you want to avoid what we call a fan out, which is having to hit every partition to go find your data. You want to hit with either one or a bounded set of partitions on the read path.
Awesome, thank you.
Okay, I think lots and lots of reading. Obviously, Azure Cosmos DB Docs is very, very good place also to go. And I know, Mark, you explain a lot of these concepts in there. I've spent a little bit of time in there myself. One of the ones, and one of the questions I wanted to ask you, Mark, was you mentioned you replicate like a lot. It was like 4 times in one region, and obviously, a Cosmos DB is naturally highly available. But how does data stay consistent?
Right. So with Cosmos, because we're a distributed data store and we replicate data across regions, we have what we call consistency policies. And this governs essentially how data is replicated or copied or persisted into remote regions. There's 2 kind of different flavors. Well, there's multiple flavors of that. We have 5 different consistency policies. There's strong consistency, which is synchronous replication. So before data can be act or committed, it has to be copied or replicated into every other region that you're replicating into, committed there, and then act back. And then we have what's asynchronous replication, and there's 4 flavors of that, and that happens depending on what the consistency policy guarantees are. So there's one called bounded staleness that has, as the name implies, it's bounded in terms of staleness, and it's usually a period of time or a number of writes or updates. There's also a consistent prefix, which is more relaxed, but all the writes are done in order, or reads you see in the order they were written. And then there's an eventual consistency, which is the most relaxed, and there's no guarantees on any of the orders. The trade-off here is you get increasing levels of throughput the more relaxed the consistency is. Strong is the worst in terms of throughput and also in terms of latency, because you have to replicate over long distances over a WAN, and the speed of light becomes an issue. And I saw a question in here about cap theorem earlier. That's absolutely comes into play with a distributed data store. You have to make these trade-offs when you're either want consistent data, you have to give up availability. If you want availability, you have to give up consistency.
Wonderful. Let's continue that conversation on the chat because we need to move on. We still have a lot of content. I want to share. So the other day, I did a call with Scott Senfield where he was demoing me some super crazy demo about a robot. So I want you to see that. Let's run the video. Hey, Scott, how are you?
Hey, Frank. It's been a while.
Yeah, indeed. Very happy to see you.
Yeah, likewise. You caught me kind of heads down working on this demo. I mean, literally, really. I'm dying to show you. This is what I'm showing next week on Tuesday, September 28th.
Oh, and excellent.
I would love to give you a sneak preview of it.
Yeah.
Okay.
Nothing is breaking yet, so it won't be my fault.
Yes. I think everything's working right now. It is another robot, cool. But the reason why it's another robot will become clear in just a moment. So I'm going to swing the camera around to it. Let me show you. Okay, we'll just dive right into it. So Let me grab this and move it down here. So this is a little device called the Quanser Cube, and it's kind of wild. It's I've had this for quite a while, and we just recently kind of brought it out of retirement because it perfectly illustrates a few of the new concepts that we're launching or demonstrating next week. So again, at 11 a.m. Pacific next week, we have a long demo set up on September 28th, and we have new features in Project Bonsai that are going to make this thing do this. And I'm running it now, and that. Okay, good.
Oh, that's cool.
Yeah, it totally works. So I want to explain why it's working. Let me put something behind it so it's a little bit easier to see the bar, and this will become clear in a moment.
And I don't see it moving, but I'm assuming it is, right?
Yes. In fact, if I knock it hard enough, now it's going to start over. There we go. Okay. So
that's cool.
This is a really interesting space because in order to keep this thing upright, it's making decisions at a very high rate of speed, and it's deciding how to move this thing in order to keep it upright. And so let me go backwards and tell you really what we're looking at. So I have this other camera that's pointing top down. So I'm going to take this top thing off just to explain it. So we have here this cube. It's a great name, the Quanser cube. It's from a company called Quanser, and they're out of Canada, and they make devices that are used to teach mechanical engineering concepts to students in university. And this particular one, it comes with an entire Simulink coursework for mechanical engineers that run simulators and learn how to do things like balance as one of its many skills. This may be something they would see. Now, but to understand this as a robot, just imagine it's controlled over USB and that we're simply telling it to either go spin clockwise or counterclockwise. And you tell it that by providing a voltage somewhere between 3 volts or -3 volts. And that determines the rate of spin. Okay. Mm-hmm. Now this looks like a motor. This looks like a motor, but it's not. This is an optical encoder. This is a passive device that it knows the exact position of this aluminum shaft. And at the end of the shaft is this weight. So we really have a pendulum, like on a clock. And with these 4 magnets, I can make an attachment directly to the motor. So we have this interesting problem in that, well, let me try to do this by hand and you'll see this is really difficult to do. The idea is just if you move this left and right, can you move it in such a way that it spins, well, eventually gets, I can tell you that I can't do this. A human can't do this. Whereas like Moab, you could maybe with a joystick move it back and forth to get it to stand upright. So by putting this on here, it receives the state of the arm in a variable called alpha. It gets the state of the arm and says, okay, well, what do I need to do to get it to stand nearly upright? But once I'm upright, what do I have to do to keep it steady? And that's a feature that we added fairly recently that we'd like to show more on the 8th. It's called multi-concepts, and we do this whole thing with something called visual editing. And so you'll see this is really a 2-step process. You have to first get close enough to standing upright, and then you move into a different mode of control. So it's kind of controls based, but the same technology is used all over our use cases in Project Bonsai.
So it's because it's not just a recipe that you could apply, like it changed, right? Because you're tapping it. So like the machine really need to take decision. This is really interesting.
Yeah. And this kind of transition state is fun. It's really fun to write code that affects and moves real things. I can't do this like with a real big industrial machine. This is a lot safer because it's on my desktop. But so yeah, we'll show more of that on Tuesday of next week.
Wonderful. So we'll share the link in our show notes. Thank you.
Thanks. Hope to see you then. Bye.
Bye. That was cool, right?
Whoa. I don't know what I was expecting because I didn't watch it prior to this. There's a little bit of excitement, but that is, that's unreal, isn't it? It's kind of bizarre. I don't know.
The time is flying. We need to move to our next speaker. So you want to make the intro, Amy?
Sure. Let's welcome our final expert, Savine, who's going to talk to us about Azure Synapse. Hey, Savine, how's things going?
Doing great. Glad to be here.
Yeah, no, thank you for joining us. As you mentioned at the start, you're connecting everything we've already spoke about, basically. And again, you had a chance to spend some time with our wonderful host, Frank, and tell us a little bit about it. So let's see the video and we'll be back for Q&A.
What is Synapse?
Well, it's a great question, a common one. Synapse is really all about doing enterprise analytics at scale. If you want to do that in Azure, there's one answer. That is Synapse. So instead of having to pick multiple technologies, which, is challenging for organizations, they really struggle with it. Different analytics engines, different data integration engines can be very complicated. The answer is one thing, Synapse.
Okay, I like it. So what's the problem does it solve for your customers?
Well, I mentioned just a second ago about having to pick and choose, right? And let's just focus on one aspect of that. Analytics engines. Mm-hmm. Now, what we see in the world is people are having to use 2 different worlds of engines, Spark and data warehousing, that, T-SQL, SQL. And these are really different worlds, different technologies, different query languages in some cases, different security models, different experiences, differences all over the place. And what we see in organizations, they're doing these enterprise analytic solutions. They're failing often. They're failing because these 2 technical silos of big data, Spark, and data warehousing SQL don't work well together, right? And because those technologies don't work well together, the organizations themselves silo the teams. In the same organization, we'll see a Spark team and a SQL team, essentially, right?
Yeah.
So, often you'll see us talk about Synapse as limitless. And often when we say that, we do mean works at any scale, any size of data. And that is what that means. But it also means erasing limits between these two worlds. We're talking about not the size of data, but erasing the boundaries so that you can have shared metadata, shared data, a unified security model, right? A unified coding experience and debugging experience and monitoring experience. All these things are the limits and the boundaries we're removing to make it one solution.
That's nice. That's nice. I really like that all together. Okay, so what's the most common scenario where people are using, or like where Synapse will shine?
Well, the most common thing that people are doing with Synapse is a pattern. It's classically known as the modern data warehouse pattern. And it's very simple, and I've seen it replicated from the smallest organizations to the largest, from gigabytes to literally petabytes, and in some cases, exabytes. And really, it's all about landing data from different sources, on premises in the cloud, into a lake in the cloud, right? Files. Then, you need a data integration system for that. And then that data has to become prepared or cooked, as we might say, cleaned up. So that's another stage in this process. And then you start using big data maybe for machine learning, training models, right? So you cook and clean, you train models, you do your AI and ML. And then finally, of course, you take that data and you put it in a serving layer. That's really the data warehousing layer, because then you use normal SQL to serve it to tools like Tableau or Power BI. So that pattern is what Synapse is just built to, out of the box, make possible quickly. And of course, as you can see, that pattern will evolve and, real-time streaming analytics gets added. So those kinds of scenarios, that's where the sweet spot is for Synapse.
Lovely. You know what? You got me hooked. Can we see it? Can you show me a little bit how it works?
Absolutely. Absolutely. So let me move over to what you can see now. This is called Synapse Studio, and this is its homepage, right? Now, I've got a lot to demo, but the easiest way of understanding what's going on here is that I have a lot of code, and I'm going to access data wherever it is. So I'm going to go to the Data Hub. And in the Data Hub, you can see I have workspace data and linked data. And then in the workspace data, I have these databases. And in the linked part of the Data Hub, I have data sources that are not in Synapse, but somewhere else in Azure. And I'll show you how Synapse just can work with all your data in Azure. Let's start with the workspace data. This is sort of the data that's owned by Synapse. Now, of course, I have a SQL pool, what used to be called a Azure SQL Data Warehouse. Now we just call them dedicated SQL pools. And in it, I have a classic native SQL table. And just to show you, of course, I can do a select top 100 on this, and it would just work, right? It's exactly what you'd expect to see in a system that uses T-SQL to query data, right? And you can see the query was written and it ran. And I'll just close that because that's what the product is supposed to do easily with native T-SQL. But what about Spark databases? Now, you can see right here, I have a Spark database, and inside the Spark database, there's a Spark table. And this is the same data, but this is a Spark table, which means the metadata is now in this Hive-compatible metastore, and the data is in Parquet files in the data lake. And I can right-click here and take a look. I can, of course, create a new Spark notebook, and that'll load it to a data frame. I'm going to ignore that for now because everyone's very familiar. Spark notebooks will work with Spark databases. What we've added is native T-SQL compatibility with Spark databases. So I can do a select top 100 rows, and it does exactly just pure normal T-SQL on the Spark database. And I can run it, and it will just kick off and finish this query. You didn't have to do anything. It will just work, right? Now, what you're seeing here is that the SQL query spun up some resources. It took about 8 seconds. If I run this a second time, it'll just work very quickly now. You can see there, it took 2 seconds, and it might be 0 seconds. It just kind of depends on the day and the time. That's using our built-in serverless SQL pool engine, right? It's a massive scale, enabling T-SQL analytics on Spark databases. So those are databases inside Synapse. What about, I mentioned, we'll work with your data wherever it is. Let's pick 3 interesting cases, right? The first is blob storage. And I have another data set in blob storage called the famous New York City taxi cab data. I'm not going to demo the query because I have the same data also in another storage account over here called in the Azure Data Lake Storage Gen 2. And if I click in here, you can see there's going to be some files here. And what I'm going to do is I'm going to query those. Now, instead of rewriting all these things, I'm going to do the right clicks and find a file here and create a SQL script or a Spark table. But instead of doing all that, let me just find a pre-built one. And so that was a file in a lake, a Parquet file. So of course, I can just query it directly. And this is what the T-SQL looks like. Again, this isn't a Spark database. This is a a Parquet file. And I can just run it. And again, it will just go kick off a query. And you didn't have to specify the schema. It just worked. It just worked. And likewise, Cosmos DB was another thing we talk about. I have Cosmos DB and I can just do a spark.read on a Cosmos DB container. And then using Synapse Link for Cosmos DB, which automatically gets data from the Cosmos DB transactional store into an analytics store, it just works in Synapse. So wherever your data is, Synapse can use it.
I love it. Very clear. Thank you for your explanation. That was super cool. I love it. We share tons of information today, and I forgot to mention because I was kind of in the moment, but we have in the show notes learning path, learning module for you, all in the show notes. So the link that's shown in the bottom of your screen where you could start learning. Very interesting. Amy, any questions that we have?
I'm not sure we have too many questions in the chat, but as you know, our speakers are here with us to answer your questions. If you don't ask them, I'll ask them. So, Sabine, I do actually have a question for you. Obviously, with data and all these different data stores, there's a lot of work that goes into getting data into those things, so data integration. How does that work with Azure Synapse and obviously Azure Data Factory? How would you choose between these things?
Well, you picked a really popular question. Let's start with the fundamental thing everyone needs to understand is that, we have these 2 products, Azure Data Factory, Azure Synapse Analytics. They share a common data integration engine, right? So literally the same code that's in Azure Data Factory that does pipelines and data flows is the same code that's in Synapse, right? So one piece of technology that's in both places, packaged a little differently. So now the question is that sort of how they relate. And there are a few differences. Sometimes Synapse has more stringent security requirements, so it takes a little longer for a feature to appear in Synapse. But our long-term roadmap is whatever's in Azure Data Factory is in Synapse. And finally, which one should you pick? If you're someone who's never done data integration before, like it's your day 0 and you're not already using Data Factory, just use Synapse. It doesn't cost you any more. It gives you even more down the road, and we think that's the right answer. If you're someone who's already got Data Factory or you're really using SSIS and all these ETL tools and you really don't care about analytics so much as you're just doing standard kind of data movement, then ADF is a great place for you, right? I hope that clarifies it.
Thank you. The time is flying. Thank you all. So in the description in the show note, I put the link to all those people so you can reach out and continue the conversation or just leave a comment. And for me, I will see you tomorrow for another episode of Hello World. Bye, everybody. And everybody's there.
Bye,
excellent.
Everyone.
Even better.
Bye-bye.